Hey guys, this is Mr. Lytle, and we're going to cover angle addition postulate. First, as usual, I'm going to start off with a hilarious joke. So here we go. Why do plants hate math? Hmm, deep thoughts. I'll give you a second to think about that. All right, are you ready? It's because it gives them square roots. Oh my gosh, it kills me. Where do I come up with these things? They're awesome. All right, now we'll get started. Okay, but before we get started, here's a little refresher. Do you remember this bad boy? Segment addition postulate. I know some of you guys were having some issues with this. So basically, once again, the postulate states that you can take the length from A to B, add it to the length from B to C, and that will give you the length of the larger segment, A all the way to C. And I also have another video covering this. So, I mean, if you guys are interested, you can always go back and look at that video. All right, so a couple practice problems using the segment addition postulate to help refresh your memory. If you don't remember, once again, segment addition postulate basically states that adding the distance from D to E and that to the distance from E to F will give you the distance or length of the larger segment, D all the way to F. So if we can take 23 plus 35, and that will give you 58. So that is the distance from here all the way to there. It's 58. Okay. Now this one wants you to find GH. That's for B. That's this distance from here to here. Well, what we could do, imagine if you could take this away from this, what would be left? The distance from G to H, correct? So what we're going to do is do 36 minus 21, and that should give us this distance here. See how much fun that was? So that would be, what, 15? If I did the math right in my head. So that distance right there is 15. So hopefully that brings back fond memories. And now we'll get started on the segment addition postulate. All right. And I know I said earlier segment addition postulate, I meant angle addition postulate. But notice some similarities with the segment addition postulate and angle addition postulate. This is basically stating that the angle RST, here's R, here's S, here's T. That's the angle stretching all the way across. You see where I'm marking? That is the angle RST. That's the entire angle measurement there. Well, like the segment addition postulate, you see the smaller angle here? This one? There it goes again. The pen just has a mind of its own. How do I get rid of that? Hold on. Well, have to pause the video and fix this. All right, sorry about that. So hopefully I can do this again without clicking on the button that's on the stylus, which keeps bringing up the letter E for some reason. So, got to choose the pen, the pen. There we go. So here's the angle RST, the angle measurement, the larger one. The segment addition postulate says you can take the two smaller angles here that I'm tracing out for you. You see those two? We can add those two together to get the entire angle measurement here. That is your segment addition postulate. And hopefully you do see some similarities with that and the segment addition postulate. So we're going to put that to practice. Here's an example problem for us to work on. So it wants us to, given the angle LKN, so here's LKN. LKN is the measurement from here all the way to here, this angle. I could have done it, made it a little smaller here, but you get the idea. So it's this angle from here to here. So given that, which is 145 degrees, we want to find the angle LKM. So LKM is the smaller angle right here. We want to find this one. And the angle MKN, which is here's M, here's K, here's N. So it's this one right here. Try not to cover up the 4x. That angle right there, these two smaller angles is what we want to find. So using the angle addition postulate, it says that you can add the two smaller angles together. So we're going to take the 2x plus the 4x minus 3. So the two smaller angles added together should equal the larger angle measurement here, the one that stretches all the way across here. And that one was 145 degrees because they told us up here that was 145. Okay, so now you have an equation to solve, which you guys, since you've had Algebra 1, should be pros at this. So we always start off here. I'm gonna start off looking over here on the left side of the equal sign. I'm gonna focus on that. I'm gonna ignore the right side for right now. And I'm gonna look for like terms on the left side to combine. You see the 2x and the 4x, let's put those together. So 2 plus 4 is going to give you what, 6x? 10 minus 3 is going to give you 7. And on the left side, I'm done. There are not any more like terms to combine here on the left side. So now I'm gonna look on the right side, just focusing on the right side, ignoring the left side. Are there any like terms on the right side to combine? There are not, because 145 is the only term over there. So we'll just carry it down. Now we worry about moving things across the equal sign. So since my goal is to isolate x, that basically means I'm going to try to isolate this entire term here. I'm going to move the 7 over. The arrow. And to do that, since this is a positive 7, I'm going to subtract it from both sides. The 145 minus 7 gives you 138. I'm going to carry this up over here where I have room. And the last step would be to divide both sides by 6. So taking 138 divided by 6, that's going to give you 23. So the question is, are we done? And the answer to that would be no, because they're not asking us to find x. We have to find x to be able to answer the question, but that is not what they're looking for. What they're wanting is the angle measurement from here to here, the angle measurement for L, K, M. If you remember how to name an angle, use the 3 points, and the vertex is the one in the middle. So LKM is going to be this measurement here represented by this expression. So 2x plus 10. And we're going to take the 23 and you're going to plug it in for x. So 2 times 23 plus 10. That's going to be what? 46 plus 10, 56. So that's 56 degrees from here to here. So 5, 6 degrees. So 56 degrees. Well, I got to find some space to work out the next problem. Let's try to see if we can fit it into here. So we're going to look for angle measurement. M, K, N. Okay. So the expression that represents that smaller angle right here is going to be 4x minus 3. You're going to plug in 23. 4 times 23 is going to be what? 92, if I did the math right in my head. Because that's going to be 12, that's going to be 8. Yep, 92 minus 3. So that's going to be 89. And so that is 89 degrees from here to here. And just for fun, we're going to add those two together. So we're going to take 89, the angle at 89 degrees plus 56 degrees. And that's going to equal 145 degrees. So the larger angle, the one stretching all the way across here, you see me tracing that right now, is 145 degrees. And another question is, what type of angle is 145 degrees? It's an obtuse angle. Well, I ran out of the room, but obtuse angle. So 145 degrees is an obtuse angle because why? Well, it's greater than 90 and less than 180. And that is it, folks. And we are done with this video. I hope you guys have a wonderful day.